Okay, we're actually going to look at the couple of the multiple choice questions that you guys missed quite a few of, and just ignore the name of that test because this is me using parts of last year's test because I used some similar questions or the same questions. Okay, so every one of these that I'm working means the class average was below a 70% on that particular question, so it will not be all of the questions, it'll just be a handful of them. So part of the thing that I think you guys struggled with when we were looking at these null and alternate hypotheses is what does it mean when things like complete the maze faster and things like that. You have to think about, like, faster doesn't mean that the sign is automatically going to be greater than, okay? If mu is the time and we want to be faster, right? So let me say that again. If mu is the time it takes them to complete the maze, and we think they might go faster, then that means our time will be less than. So our time will not be greater than, but rather our time will be less than. You have to think about the alternate hypotheses in context of the problem, and this happened twice to you guys. So it definitely happened on this first one. And then it happened to you again on the resting heart rate one, right? It said less fit, and because it said less fit, most of you put the less than option. And so less fit, when we're talking about our mu being beats per minute, less fit means you are going to have a faster heart rate. Maybe you guys just don't know that, but like long distance runners have an average heart rate of like 45 to 55 beats per minute, where the average person has an average heart rate of like 80 beats per minute. So the more in shape you are, the slower your heart rate is, the less fit you are, then you're going to have this faster heart rate, meaning you think it's going to be above 72 beats per minute. Okay? So just keep in mind when you're reading words like less or more, that doesn't mean that's going to define your inequality symbol. You have to read the word less in context of the true mean, or mu. All right, moving on to question number 6. Or not number 6. It was I don't know what number it was on your test. Says, which of the following describes a type 2 error in this setting? And we're referring to the resting heart rate one, right? So type 1 error means I reject the null, and I shouldn't have. Type 2 error means I reject the alternate, and I shouldn't have. And so if I reject this means less fit, right? That's what this means, less fit. I actually just wrote a really bad word. Let me try that again. Less fit. There we go. So I'm rejecting that they're less fit, and I shouldn't have. By the way, anyway, so that's what this means. Not concluding that the students are less fit as the general population when in fact they are less fit. Okay? So if that's the error, then that is the problem. Okay? Okay, moving on to number 8. Number 8 says a significance test was performed to test the null hypothesis, which is the P equals 0.5 versus the alternate hypothesis, which is that it's greater than 0.5. Our test statistic, they actually just went ahead and gave us Z, is 1.40. And it wants to know which of the following is a p-value for this test. So I've got two options right now. I can go to the table, and the table would be a Z of 1.4. So that looks like this right here. Remembering that if I'm talking about z-table, the area is collecting from left to right, right? So 0.9192 is everything leading up to that z, okay? But because of what our alternate hypothesis is, right, so if this is our mu, or in this case 0 because we went to z's, here's 1, here's 2, so here's 1.4. What that means is everything up to this point is going to be 0.9192, right? But our alternate hypothesis is that our proportion is going to be greater than that. So we're actually looking at this portion. So I'm going to have to take 1 minus 0.9192, and my answer will be that 0.0808. I also have the option of using normal CDF. So it's in Chinese. Okay, so 5-1. No, it's okay. I can go back to English. English. Has to think about it. There we go. So let me darken this just a little bit so you can see it. I'm going the wrong way. Nope, I was going the right way. Okay, so we're just going to go to a calculator page and go to menu, go to statistics, go to distributions, go to normal CDF. Our lower bound is going to be 1. I've forgotten. What is our z? 1.40. And our upper bound, I know this is a little difficult to see because I've got this like window right here. There we go. Our upper bound is 99999999999, right? And we're going to leave our mu as 0 and our standard deviation as 1 because we're on the normal curve, and because we have a z-score, we standardize our score to a mean of 0 and a standard deviation of 1. So I'm just going to hit OK on this, and it's going to give me that 0.0808 value for my probability, my p-value. Okay, so next question says, this time our null is a 0.7 and our alternate is not 0.7. So remember, this does not equal to puts me in the two-tail zone. And so they're giving me a z value of 0.8. And I want to be careful here to make you understand this. Like if I have a z value of 0.8, it's 0.7881 according to this chart, right? So this is why I always like for you guys to draw pictures, because here's what just happened. That number, right, if this is 0 and this is 1, I don't know why I put that there, 0.8, this z value of 0.8, that's giving me all of this. Okay, so let's see, that was 0.7881. Now, if I want the tail, I could look at negative 0.8, and that would give me this part. But I can also just subtract from 1. So that would be 0.2119 here. And then I have matched the tail here, which gives me the two-tail of 0.4237. Okay? So if I subtracted from 1, I would get this, and that would actually give me this side first, and then I could reflect it over here. Or I could do a negative 0.8, and from the z-table, when I look at negative 0.8, Oops. There we go. Sorry, just flipping around over here. So if I look at negative 0.8, that's 0.2119. And that's that one tail. And you have to multiply it times 2 or add it to itself to get the 2 tail. Okay? So be careful. Our answer is this because it's 2 tail. A lot of people answered this, which is the 1 tail answer. Okay, moving on to number 10. Tricky of me. I didn't give you a proportion, and because I didn't give you a proportion, that meant you had to use 0.5. So remember, if one's not given, assume it's 0.5. Number 11, I know this is tricky. Yes, our data does have to be approximately normal. No, we don't care that this happens in normality. In normality, we want this to be true. Unless the sample is large, if the sample is large enough, this is going to happen. So this, unless the sample size is large, this is the part that's not true. Yes, we want the population distribution to be normal, but it isn't absolutely necessary if we can prove 0.1 or 0.1. If we can prove p times n and p times 1. Wow, I don't know what's wrong with my words. 1 minus p times n. Okay, so not an absolute if we can prove it. Yeah. So, okay. Number 12. The z statistic for the null hypothesis is 0.4. The alternate is larger than 0.4. Z is, and I really think what happened for a lot of you on this test is like, oh, I don't know what to do with a z value, which is sad. Made me sad. I failed you. So I'm just going to go to the table and look up z is 2.43. 43, this is 0, 1, 2, 3. So 0.9925 is what I'm getting from, where am I at? Oh, there it is. 0.9925 is what I'm getting from the table, but remember, 2.43, it's giving me this huge thing right here. So if I take 1 minus 0.9925, I'm going to get 0.0075, which is less than 5% and also less than 1%. So it works for both because it's less than both. Which of the following 95% confidence intervals would lead us to reject p equals 0.30 in favor of not 0.30? So you're looking for the one that doesn't include 0.30. Right? We reject if the null hypothesis is not in the interval. Let me say that again. We reject if the null hypothesis is not in the interval. Really important concept to understand there when we're talking about using our significance, using our intervals as a significance test. All right. Number 18, a little tricky. In fact, I had to read this one twice to feel confident about it. It turns out that it's significant for 39.92 seconds, which, great, but doesn't help me, right? Like, yes, we can say it's statistically significant, but like, I just shaved off 0.08 of a second. That is not practical. Like, there's nothing exciting about that. So this was tricky because we've talked about just reject. But sometimes you need to think about the context of the problem and ask yourself, so what? All right. Oh, I've gone in a weird order. Okay, so I need like 5 minutes. If you'll just, she can come in. I'm making a video, so just quiet for like maybe 5 more minutes. Okay. Yeah. Okay. So in this one, our null hypothesis is 60, and our alternate hypothesis is greater than 60. X bar is 58 and our p-value is 0.04 with an alpha level of 0.05. And it wants to know what's the appropriate conclusion. So our p-value is less than our 0.5 alpha level. So we reject the null hypothesis and we say yay to the alternate hypothesis. And quite a few of you marked that we have insufficient evidence to conclude that 60. Remember, we're always trying to say something about the alternate hypothesis, right? We're trying to say something about the alternate hypothesis. We're trying to prove the person is guilty. We never say we have sufficient evidence to say the person's innocent. We say we don't have sufficient evidence to say they're guilty, or we do have sufficient evidence to say they're guilty. Same thing with the alternate and the null here, is you have to be careful of what you're concluding. All right, number 16. Guys, there's no procedure necessary for this problem. They're just talking about how much they made. They're not asking any questions. They're not asking you to prove or verify anything. So none of these. And then 18. Nope, we did that one. Sorry. 20. We ran into the same problem again. And I really believe it's this issue of not knowing how to read the table correctly. So T is negative 2 point, sorry, I'm going to my T table here. T distributions. Actually, it's not on our table, so we have to go to the calculator. So this time we're going to go menu, statistics, distributions, get that TCDF. We want negative less than 10 at negative negative 2.25. So that's negative 999 up to negative 2.25 with 19 degrees of freedom. And our answer from our calculator, sorry, you can't see that again. Here we go. Our answer from our calculator is 0.018, which is between 0.01 and 0.02. Remember, if your t value is not on your table, you've got to go to that TCDF function in your calculator to get the appropriate p value. All right, guys, I hope that was helpful for getting ready for your FRQ tomorrow. And good luck.